Yeah, hello guys, you are welcome to my YouTube channel Mathematics Made Easy. So in today's video, we'll be looking into an important theorem in calculus, and then we'll be solving an integral as an example. So now let f of x be an even Riemann integrable function on the interval minus alpha to alpha, and also we have gx, an odd Riemann integrable function on minus alpha comma alpha. So where alpha is an element of the real number. So then we then have integral from negative alpha to positive alpha of f of x over 1 plus b raised to the power of g of x dx equals integral from 0 to alpha f of x dx. Then x prove that relations, and then also use the information provided above to solve the below integral, which is integral from negative pi to positive pi of sin square x over 1 plus e raised to the power of x raised to the power of 3. Okay guys, so let's get started. Let's solve the question. Okay, solution. Now the first thing is to prove that relation, that is, we want to prove that integral from negative phi to positive phi, then of f of x, then over 1 plus b raised to the power of g of x dx equals integral from 0 to phi f of x dx. So that's the first thing we want to do. We want to prove this. Now proof. Now note that if you have an integral, that is, you have an integral function f of x minus alpha to positive alpha of f of x dx. So this is the same thing as integral from negative alpha to 0 f of x dx, then a plus integral from 0 to alpha, then f of x dx. Take note of that. Okay, so we are going to rewrite this integral as integral from negative alpha to positive alpha of f of x, then over 1 plus b raised to the power of g of x dx. So this will be equal to integral from negative alpha to 0 of f of x, then over 1 plus b raised to the power of g of x dx, then a plus integral from 0 to alpha of f of x, then over 1 plus b raised to the power of g of x, then dx. Okay, so I can name these two integral. So I can say this is integral I1 and this is integral I2. So we can say that I equals integral I1 plus integral I2. Okay, let's just deal with integral I1. So we have integral I1 is the same thing as this integral right here, which is integral from negative alpha to 0 of f of x, then over 1 plus b raised to the power of g of x, then dx. Okay, then we can make a substitution here by let u equals negative x. So if u is equal to negative x, then we're gonna have the u equals minus the x. So then if you have the u equals minus the x, then don't forget that the limit is going to change. That is when x is 0, so you're going to have u equals 0, and when x is minus alpha, so you have u equals alpha. So you're going to have I1 equals integral from alpha to 0, then f of minus u, you have u equals negative x, so x will be minus u, then over, so we are going to have, sorry, then over 1 plus b raised to the power of g, then raised to the power of minus u, then we have the x, so the x will be negative du. Okay, we have negative du. Now let's move on. So using the information given, we know that f of u is an even function, and then for a function to be an even function, so if we have f of minus u, so this will be the same as f of u, so that shows that it's an even function. And then we know that g of u is an odd function. Okay, is an odd function, that is if you have g of negative u, this is equal to minus g of u. Okay, so now using this information that is given from the question, so we are going to have this. So we have I1 is equal to integral from alpha to 0, then of, instead of writing f of minus, you will write f of u, then over 1 plus b raised to the power of minus g of u. So instead of writing g of minus u, you write minus g of u, then we have minus du. Then don't forget, if you have an integral this like this, and you're having negative du, so you can switch the limit, then this negative sign will move out. So you're going to have integral 1 equals integral from 0 to alpha, then f of u, then over 1 plus b raised to the power of negative gu, then du. Okay, since we have this now, what do you think we can do? Okay, the next thing we are going to do is to if you factorize b raised to the power of g of u out, that is, if you factor this b raised to the power of g of u out from the denominator, so we're going to have I equals integral from 0 to phi, then f of u multiplied by b raised to the power of gu. You understand? So we're going to have f of u multiplied by b raised to the power of gu, then everything over 1 plus b raised to the power of gu, then du. So this is what you're going to have. So that's your I1. Okay, guys, so you can replace u by x, I mean with x. So if you do that, you're going to have I1 equals integral from 0 to alpha, then f of x, so multiply by b raised to the power of g of x, then everything over 1 plus b raised to the power of g of x dx. And then remember that I equals I1 plus I2. Okay, don't forget this is same thing as I1. And then we have our I2. Our I2 is f of x, integral from 0 to alpha, f of x over 1 plus b raised to the power of g of x. So we're gonna have I equals I1, which is integral from 0 to alpha, then f of x multiplied by b raised to the power of g of x, then everything over 1 plus b raised to the power of g of x dx, then a plus I2, which is integral from 0 to alpha, then f of x over 1 plus b raised to the power of g of x, then dx. Now, if you notice, they both have the same denominator, so the LCM will be 1 plus b raised to the power of g of x. So that will be the LCM. So then we're going to have I equals integral from 0 to alpha, then into bracket 1 plus b raised to the power of g of x, then multiply by f of x, then everything over 1 plus b raised to the power of g of x dx. Okay, so we have 1 plus b raised to the power of g of x. We cancel out 1 plus b raised to the power of g of x. Then we have I equals integral from 0 to alpha, then f of x dx. So that is proved. All right, so that is proved. So prove that function there. I mean, that's Riemann integral there. Okay, now the question say we should solve, we should use the given information to solve this given integral from negative pi to positive pi of sine raised to the power of 2 of x, then over 1 plus e raised to the power of x raised to the power of 3 dx. Okay, what thing we can do now? So f of x is the numerator, which is sine square of x, sine square of x, and then we can see that this is an even function. Okay, so sine square of x is an even function, and then more so, x raised to the power of 3 is the g of x, so we have g of x equal x raised to the power of 3, and is an odd function. Okay, it's an odd function. So f of x is an even Riemann integrable function, and g of x is an odd Riemann integrable function. Then over the interval minus pi to pi, so over the interval minus pi to pi, then since f of x is even and g of x is odd, then we have integral from 0 to pi, then of sine square of x dx. Okay, you know, like how we got this answer here. So then we have integral from 0 to pi of sine square of x dx. Then if you integrate sine square of x, so I don't need to do that, so you can check my videos on that. So you're gonna have 1 over 2, then multiply by x minus sine x cos x, then from 0 to pi, then you apply your limit. Then if you do that, you're gonna have pi over 2. Okay, so you're gonna have pi over 2 as the answer. So therefore the integral from negative pi to pi of sine square over x over 1 plus e raised of x raised of 2 dx will result to pi over 2. All right guys, thank you for watching. So if you like this kind of video, don't forget to like my videos, subscribe to my channel, and then share. Thanks for watching. See you next time.